My name is Ephraim Zimmerman, and I'm the Science Director for the Pennsylvania Natural Heritage Program at Western Pennsylvania Conservancy. Understanding what plant species may thrive at a particular site is important in ecological restoration. This greatly benefits from a solid understanding of the site's ecological characteristics. Identifying a target natural plant community can be a key component to a successful restoration. Today, I will be presenting a new tool, the Community Restoration Targeting Tool, developed by PNHP and NatureServe, which uses our plots database and geospatial information to determine the plant communities and plant species that may exist at a particular restoration site based on their similarity to sites classified to a specific plant community by PNHP. In addition to inventorying the state's rare plants and animals, a primary focus of PNHP has been the classification and description of plant communities in Pennsylvania. Association level plant communities form the basis of the Community Restoration Targeting Tool. The Heritage Program's definition of plant communities is similar to most state natural resource agencies and NatureServe, definition focusing on the plants themselves. Plant communities are groups of plant species sharing a common environment that interact with each other, animal populations, and the physical environment, existing in repeating patterns across the landscape. Why do we use plant communities? Well, they're mappable units of the landscape. Conservation actions that protect plant communities also protect the rare species there. They're identifiable starting points for biological surveys. The plant communities are also repeating patterns in vegetation that tell you something about the ecological conditions of the site. Most of all, the communities can provide a list of plants to guide restoration activities. Pennsylvania Natural Heritage Program has developed a number of tools that provide practitioners with information on plant communities, which can be used to learn more about the composition and structure and associated environmental variables. They're defined by diagnostic and characteristic plant species and associated ecosystem variables and processes. And they're crosswalked to the National Vegetation Classification System. This crosswalk allows us to communicate in a single language with partners outside of our state. We also have a number of identification keys and a gallery of photos available on our website. Communities in the plant community classification are supported by quantitative vegetation plot data. Plots representing wetlands, uplands, forests, and non-forests have been acquired through projects starting in the late 1990s. And in all, our database has over 2,500 plots and over 4,000 accuracy assessment plots. We analyze our data to support communities. In other words, groups of plots representing similar vegetation and ecological variables. For example, this group of northern hardwood forest plots occurring in north central Pennsylvania, and these are all supported by non-parametric statistics. Unfortunately, our plant community classification and keys do require a fairly high level of botanical knowledge. They often fail to recognize variation and subtleties in community structure and composition of a particular site. So they're not site-specific. It's also not necessarily user-friendly or interactive. We wanted to change this. But because of our community classification data set, we have a robust guide for restoration activities, if it can be accessible. So we wanted to take advantage of our large geographically specific data set with information on community structure and composition and associated ecological data to guide restoration efforts. We thought that if a user could provide environmental data, we could determine which plant community or communities might be good matches for the site based on the collection of quantitative plot data that we have. This isn't something that's new or novel. it's been created in a number of other states. The particular tool was first developed by the Carolina Vegetation Survey to inform state wetland restoration and mitigation efforts. The CVS tool is designed in Microsoft Access, which references the Carolina Vegetation Survey's plots, a database of over 6,500 plots in the Carolinas. The West Virginia tool used the same framework to create a regionally specific plots tool based on their plots database for West Virginia. It has around 4,000 plots. Both of these compare the ecological variables at a site with a group of plots in the database classified to a specific community, and then produces a species list. We partnered with these efforts to develop a similar tool for Pennsylvania with the understanding that it could be updated as we get new plot data and that it was available online. The Pennsylvania version compares sites classified to classify groups of plots in our database using high quality environmental data in GIS, in addition to our field data. The tool uses model data as well, using NatureServe's habitat suitability modeling, and accesses our database of over 2,500 plots and 4,000 accuracy assessment points for vegetation comparison. So each plot has field data and spatial data associated with it. The tool then results in a matrix of vegetation types and variables for ecological values. The values are averaged for each community group to get a mean value for each environmental variable. So we have our vegetation types down this side of the matrix and eco variables across the top. So for a practitioner, you can run the same analysis on a site, on any site, your restoration site, to obtain the ecological variables of your site specifically. And then the tool applies the same process to the sites defined by the user to obtain the potential vegetation types. The ecological variables are acquired in GIS from an ArcGIS online web mapper. And the user navigates to the exact location to obtain the data. You do have the opportunity to override this with specific field data for some variables that are relatively easy to acquire in the field, slope and aspect, for example. The tool then compares the similarity to the site to each vegetation type for each variable. The similarity between each variable of the restoration site and community groups is calculated using the difference between the mean values of the plots in your site. Identical sites would have a similarity index of 100%. The tool reports then a list of community types exhibiting a high similarity to your site. The tool then selects plots and then species. The user can select, the user could then select plots from one or more targets. They can refine the list of plots even further based on the desired physiognomy, shrubland or forest, or wetland status. The tool then assembles a planting list for the most common species for each target. So we're not done with this project just yet, so I can't take you to a live version, but we hope to be finished by the end of 2020. We need to develop a landing page and the permissions and login information, and we actually even have to come up with a name for it. And ongoing efforts are we're going to continue to do plot assessments. Does it work better for some communities and not for others? Do we need to weight certain variables differently to get a better result? So we need to do testing, and more testing. We're also looking forward to training our wetland practitioners in Pennsylvania, our regulatory biologists in our Department of Environmental Protection and Conservation and Natural Resources. And we hope to do this also in the next coming months and throughout next year. Thank you very much for letting me talk about this project. We're really excited to see what we can do. Thanks.